With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, I am your teacher for this question, and the question is 2 mole equimolar mixture of Na2C2O4 and H2C2O4 require V1 liter of 0.1 molar KMnO4 in acidic medium for complete oxidation. The same amount of mixture required V2 liters of 0.2 molar NaOH for neutralization. The ratio of V1 and V2 is. So in this question it is given that an equimolar mixture of Na2C2O4 and H2C2O4, it requires V1 liter of 0.1 molar KMnO4 for complete oxidation, and the same mixture requires V2 liter of 0.2 molar NaOH for neutralization. And it is given that the mixture is equimolar and the moles are also given 2 moles. So we have to calculate the ratio of V1 and V2. So first, when this mixture is completely oxidized using KMnO4, it will be reduced as the oxalate ions from Na2C2O4 and C2O4 negative will get converted by the permanganate ion from the KMnO4 to carbon dioxide, and it itself get reduced to Mn2 positive. So it means when complete oxidation is done, the equivalence of Na2C2O4 and H2C2O4 will be equal to the equivalence of the KMnO4 solution. So we can write equivalence of Na2C2O4 plus equivalence of H2C2O4 will be equal to equivalence of KMnO4 solution. Now, number of equivalents are calculated by the formula. Number of equivalents can be calculated from it can be calculated from normality, as normality is equal to number of equivalents of the solute upon volume of solution in liters, or the number of equivalents are also equal to number of moles into n factor. So n factor is the valency factor, that is the total change in the oxidation state. So we will see, as the oxalate ion from Na2C2O4 and oxalate ion from H2C2O4, it has the oxidation state of carbon has the oxidation state of +3 in it, and when it is oxidized to carbon dioxide, its oxidation state is +4. It means one carbon, when it changes to +4, one electron is required, one electron is lost for oxidation. So for 2 carbon, 2 electron loss. Now it means the n factor for the oxalate, or we can say Na2C2O4, will be 2, as the total change in oxidation state is 2. Similarly, the n factor for H2C2O4 will also be 2, because the same oxalate ion is present, and the equivalent factor for KMnO4 would be, because the oxidation state of manganese is here +7 and it is going from +7 to +2. It means reduction is taking place by the gain of 5 electrons. So the n factor for KMnO4 will be 5. So now we can equate the equivalence of Na2C2O4 plus equivalence of H2C2O4 equal to equivalence of KMnO4 solution. So they will be as equivalence of Na2C2O4 solution will be number of moles of Na2C2O4 into its n factor. Number of mole is given, total moles of the mixture are 2 mole, and it is given equimolar mixture. It means the moles of Na2C2O4 is 1 and moles of H2C2O4 is also 1. So we can write its number of moles is 1 into its n factor is 2, plus the number of moles of H2CO2 will also be 2 into its n factor, that is 2, equals to, now the number of equivalents of KMnO4 are calculated as normality into volume, but here it is given the molarity, and we know that normality is equal to molarity into n factor. So here we can use molarity into n factor into volume for the number of equivalents. So molarity is given 0.1 molar, its volume is given, its volume is V1, and its n factor we have calculated as 5. So we can calculate V1, that is volume of KMnO from here. It is 2 plus 2, that is 4, and 0.1 into 5 is 0.5 V1. So it will give us V1 as 4 by 0.51, that is 8 liters. Now in the second part of the question, it is given that the same amount of mixture required V2 liters of 0.2 molar NaOH for neutralization. For in the neutralization, only H2C2O4 will react with NaOH as it is an acid, but Na2C2O4 will not react as it is a salt, so it will not get neutralized. So we can say that only H2C2O4 will get neutralized with NaOH solution. So the number of equivalents of H2C2O4 will get equal to the number of equivalents of NaOH. Number of equivalents of H2C2O4 will be equal to the number of equivalents of NaOH solution. Now the number of equivalents of H2C2O4 we have calculated above also, as it number of mole is 1 and valency factor is 2, and number of equivalents of NaOH can be calculated as molarity into volume into n factor, and n factor for NaOH can be calculated as NaOH in solution, it will give Na positive and OH negative ion. So the total charge on the anion or cation is 1. Either on cation it is +1 or on anion it is -1. So the charge is 1. So its n factor will be 1, and its molarity is given 0.2 molar. So it will be 1 into 2 equals to molarity is 0.2 molar, and V2 we have to calculate, and NF is 1. So 2 upon 0.2 is the V2, that is, so it will give us 10 liters. It means V2 is 10 liters. Now we have V1 equals to 8 liter and V2 equals to 10 liter, and we have to calculate the ratio of V1 to V2 as asked in the question. So it will be V1 by V2, that is 8 is to 10, 2 4s are 10, 2 4s are 8, and 2 5s are 10. So it is 4 is to 5. So the option C is the correct option, that is 4 is to 5. So I hope you understood the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.